Welcome back, everyone. Ready to dive into another fascinating corner of the crypto world.
Always.
Today, we're taking a closer look at something many of you have probably heard about, especially if you're deep in the Ethereum world. EIP-1559.
Ah, yes. EIP-1559.
Yeah. But we're not just going to skim the surface with this one.
Oh, no.
We're going deep.
Love it.
And for this deep dive, we'll be guided by Mark O'Dian's paper.
Right. The one from August 2024.
That's the one. EIP-1559. Separating mechanisms from memes, remember?
Yeah, catchy title.
Definitely. So while Ultrasound Money is a fun meme, and we'll touch on that later,
Okay, yeah.
we really want to understand the mechanics, the real nitty-gritty of how EIP-1559 actually works.
Makes sense. Get past the hype.
Exactly. And that means exploring the problems it was designed to solve.
Oh, there's some big ones.
Right. And then we can even consider, maybe what possibilities it unlocks for the future.
The future. Always exciting.
So to kick things off, I got to ask, what were the major challenges, the real headaches that Ethereum was facing with its transaction fees, before EIP-1559 came along?
Okay, so picture this. Users are basically in this blind bidding war to get their transactions processed.
Oof, that sounds rough.
It was. That's essentially what the old first price auction model was all about.
First price auction?
Yeah, and it created a ton of uncertainty.
Like how so?
Well, users would constantly overpay to try and get their transactions through faster.
We didn't know what to actually bid, basically.
Yeah, exactly. And that wasn't even the worst of it.
Oh, there's more.
Oh, yeah. This whole system was ripe for manipulation. I mean, there were these dark markets popping up.
Dark markets for transaction fees? Seriously?
Seriously, it was pretty wild. Basically, users would make side deals with the block producers to, jump the line.
So they were just bypassing the whole system entirely?
Yep, totally circumventing the process. It was pretty messed up.
So then EIP-1559 comes into the picture.
Right. EIP-1559, it swoops in with this whole new approach.
A more structured approach, I'm guessing.
Oh, definitely. Way more structure.
Yeah.
And way more transparency, too, which is huge. It uses an algorithm.
An algorithm for what?
To calculate a base fee.
The base fee, okay.
Yeah, for every single block based on how much demand there is on the network at that time.
Okay, so walk me through how this base fee thing actually works.
Yeah.
Practically.
All right, so the system looks back at the previous block, looks at how much gas was used.
Gas meaning?
How much computational power it took.
Right.
So if the previous block was totally full, packed with transactions.
High demand.
Exactly. The base fee goes up for the next block.
Makes sense. Try to keep things balanced.
Yep. And conversely, if the previous block had room to spare, less demand.
The base fee drops.
Right.
Yeah.
It's dynamic. It's constantly adjusting in real time to match what's going on.
That's a much smarter system than just guessing.
Right. Way smarter. Yeah.
So now we've got this base fee that's constantly fluctuating based on demand. What happens to this base fee once it's, collected?
Okay, here's the kicker. It's burned.
Wait, burned? Gone?
Gone. Poof. Destroyed.
What? Why would they do that? Couldn't they use it for something else?
Well, this is where it gets really interesting. Burning that base fee is actually super important. Security. And to prevent those block producers from messing with the system.
Okay, I can see how that might cause problems.
Oh, yeah. If, all those fees were sent to some central authority, it'd be a recipe for corruption.
Oh, yeah.
But by burning the fees.
No one can profit from, manipulating the base fee?
Exactly. It keeps things fair. It's kind of like the best way to guarantee that no one can rig the game.
Okay, yeah, that makes a lot of sense.
Yeah.
But, users still need to pay to get their transactions included, right?
Oh, absolutely. There are still fees.
So how does that work?
On top of that base fee that we talked about, users can choose to include a priority fee.
A priority fee?
Think of it like leaving a tip.
So the bigger the tip, the faster the transaction.
Exactly. It's a way to incentivize those block producers to include your transaction more quickly.
So if I really need something to go through ASAP, I can bump up my priority fee.
Exactly. It gives you more control, right?
Right. Okay, so we've got the base fee, which is burned, and then this priority fee, which goes to the block producers.
Right.
Is there anything else users need to think about when it comes to these fees?
One more thing. Users also set a fee cap.
A fee cap.
Yeah, a maximum limit. It's the absolute most they're willing to pay.
So kind of like a safety net.
Exactly.
Yeah.
It prevents you from accidentally overpaying if the network gets super congested.
So the system won't ever charge more than that fee cap, even if the base fee and the priority fee add up to more than that?
Nope, never. It's there to protect you.
I like that.
Yeah.
Okay, so that's the basic idea, right? Base fee gets burned. Priority fee goes to the block producers, and users set a cap to keep themselves safe.
You got it.
Okay, so we've got this this pretty clever system, right?
Yeah.
With the base fee kind of keeping things stable, and then the priority fee that lets users speed things up if they need to.
Right.
But then there's this whole other concept, multi-dimensional fee markets.
Yeah, multi-dimensional fee markets.
What even are those?
So EIP-1559, it wasn't just about fixing the immediate problems.
Right.
It was like they were setting the stage for something bigger.
I like that. Thinking ahead.
Yeah, exactly. And multi-dimensional fee markets, that's kind of where that thinking goes.
So in simple terms, what are we talking about here?
It's like recognizing that different resources on the network, they have different needs when it comes to fees.
Okay.
Like different demand patterns.
Give me a concrete example. Help me wrap my head around this.
All right, let's look at EIP-4844.
EIP-4844.
Okay, this was implemented back in March 2024.
Okay.
And it brought in these things called data blobs.
Take up blobs.
Yeah, basically there are these like big packages of data that can be published on Ethereum.
Okay.
But here's the thing, they don't actually interact directly with the execution layer.
It's like a separate storage system almost.
Yeah, exactly. It's like a separate storage space within Ethereum.
Interesting.
And these data blobs, they have their own fee market.
Of course they do.
It's all about data gas.
The data gas.
Separate from the execution gas that's used for the transactions and smart contracts.
So we're separating things out even further.
Yeah, and that's the key. It gives you more fine-grained control over the fees.
More efficient.
Way more efficient. Because you're not letting one type of demand, like, mess up the other.
So give me an analogy here. Help me understand why this separation is such a big deal.
Okay, imagine if every time you saved a file on your computer,
Okay.
it suddenly slowed down all your programs.
Woof, that would be so annoying.
Right. That's what we're avoiding here.
By having these separate fee markets.
Exactly.
Okay, so this is all pretty cool, right? We're making things more efficient, more organized. But where else could we go with this? What other applications are we talking about with these multi-dimensional fee markets?
Oh, there's so many possibilities. It's exciting. We could have separate fee markets for like bandwidth,
The bandwidth,
storage, maybe even privacy enhancing features.
privacy enhancing features. Wow.
Yeah, it's pretty wild. Think about it. Developers could actually design fee mechanisms that perfectly match what their applications need.
That's a really cool idea. So much flexibility.
Right.
Okay, so EIP-1559, it really did set off this like chain reaction of innovation when it comes to these fees on Ethereum.
It did, yeah.
But I can't help but think back to that ultrasound money thing.
Yeah.
Where does that fit into all of this?
Okay, so Ultrasound Money, it's all about this idea of a monetary premium that comes with ETH.
Monetary premium.
It's basically the value that people give ETH, but it's beyond just like its utility as a way to pay transaction fees.
It's like it's worth more than just its functional value.
Exactly. It's
Yeah.
like a rare collectible.
Okay, yeah.
It's more than just what it does.
So are you saying EIP-1559 is like solely responsible for this monetary premium?
Not solely, no.
Yeah.
I mean, the fee burning, it definitely plays a role.
Right. Less supply, more demand.
But there's a whole bunch of factors at play here.
Like what?
Think about like its role in DeFi, NFTs, all the innovation happening on Ethereum.
Right. It's the foundation for so much.
And then there's just this general belief in its potential.
The long-term potential.
Yeah,
So EIP-1559, it's a big deal,
definitely.
but it's just one piece of the puzzle
It is, yeah.
when it comes to understanding why ETH is so valuable.
For sure.
Wow. Okay, so we've covered a lot of ground here.
We have.
From like the very basics of how these transaction fees work to like this big picture stuff about the monetary premium and the whole Ethereum ecosystem.
It's a big topic.
It is. But for you, what's the most important takeaway from all of this?
You know, for me, it's the design. The way they designed this thing, it's pretty elegant, really.
Elegant, okay.
And they were thinking ahead. you know?
Yeah, we talked about that.
It wasn't just a quick fix. It was like, how do we build something that can adapt and grow with Ethereum?
A foundation.
Yeah, exactly. And the multidimensional fee markets are a perfect example of that.
Right, like recognizing that different resources need like different approaches.
Right, and that opens up so many possibilities.
Okay, so this whole concept of multidimensional fee markets, we've been talking about it in the context of blockchain.
Right.
But it's bigger than that, isn't it?
Oh, absolutely. Way bigger.
Like, where else could we apply this kind of thinking?
Well, think about any system where resources are limited and you need to figure out how to distribute them fairly and efficiently.
Give me some examples.
Sure, like bandwidth management,
Okay, yeah.
how we store data, even something like traffic flow in a city.
Traffic. Really?
Yeah, think about it. You've got limited space on the roads.
Right.
How do you make sure everything moves smoothly? Dynamic pricing, responsive allocation. These ideas from EIP-1559 could be applied to all sorts of problems.
That's pretty mind-blowing. Like this thing from the world of crypto could actually help us solve real-world problems.
It's exciting to think about.
It is. Okay, so we started with these transaction fees. We explored how EIP-1559 changed the game. We even talked about the monetary premium of ETH and what that even means. And now we're talking about like the future of resource allocation. It's been quite a journey.
It has.
But I think the big takeaway here is that EIP-1559, it's not just a technical upgrade, it's a story. It's a story about innovation and problem solving and how this decentralized ecosystem, it keeps evolving, keeps finding new ways to get things done.
And it's not over yet.
Right, like Ethereum, it's always changing.
Exactly. So who knows what the future holds for these fee markets?
Yeah, but it's going to be fascinating to watch.
Definitely.
Well, that brings us to the end of another deep dive.
Another one down.
Thank you so much for joining us as we explored the ins and outs and all-arounds of EIP-1559.
It's been a pleasure.
And until next time, keep those brains budding and keep exploring this amazing world of blockchain. We'll see you soon.